I lead product management for AWS Lambda in my spare time. In my main time, I'm here blocking you all from lunch. So let's get right to it. My serverless has been around for a decade now. And in this time, usually if a technology manages to stick around, there's always biases that build up and about what the technology can do, cannot do, and so on. And 2025 in particular has been a transformational year for Lambda, for serverless, because we've built a bunch of new capabilities that enable entirely new classes of workloads for you to service, with serverless. And let us get to it. I just have 20 short minutes with you. I want to cover as much as possible. Before we get into the launches, a key differentiation of why should Lambda exist in this world? A lot of customers ask us that. Believe it or not, it's been 10 years, but still. The main aspiration that we have to give to customers and to builders is speed. Now, speed not just in code generation, that generative AI can take care of it for you, but also the whole shipping cycle. Code generation just one piece, but then you have to ship faster, and if you ship faster, you're able to build engaging applications, collect more iterations from your users, feedback from your users, iterate on the application, and so on. We try to make sure that our application is well architected by default. So we try to do this by enabling or taking care of all of the ilities for you, the scalability, availability, reliability, and many such more ilities. And again, the primary benefit is there is no infrastructure to manage. It reduces a crap ton of operations for you that enables you to get, again, more speed. So I've bucketed the launches into three sort of cohorts. First is the new primitives. This allows you to do entirely new classes of workloads that what you could not do before. We're delighted to introduce Lambda's managed instances for you. So the mental model here was, customers tell us that Lambda or serverless really shines when you have needlepoint workloads. When you're 700, 800xing your traffic, from zero, and then your scale to zero is again important to you. In those use cases, Lambda was really fantastic. But when your application achieves, a really good level of adoption, scale to zero is no longer important. There's always some traffic, some users to serve. At that time, I'm calling it steady state traffic. So for steady state traffic, what builders wanted to do was to optimize performance, by way of adding, let's say, more network or memory or compute specific instances. So managed instances allow you to do that. You can choose where to run your Lambda function, what instance. They wanted to still benefit from fully serverless operations with the same developer experience. So you have all of the same event source integrations, patching, routing, scaling, we do all of that for you, still with the managed instances, and optimize costs. So if you know Lambda today, if you use Lambda today, it is single concurrent. One execution environment serves only one request. That was inefficient for some classes of workloads. With this, we're also adding the concept of multi-concurrency. So multiple requests can hit the same execution environment to be serviced there. And when you comply, or when you bake in EC2's pricing incentives like savings plan, reserved instances, your savings really, really magnify. So that's the key benefit here. I do realize that adding servers to serverless is a bit of a mental model shift. So we tried to make it as intuitive as possible. The only additional thing that you have to do is to create this concept called a capacity provider. There's APIs for it too, but and console obviously. But in the capacity provider, you give it your preferences on what compute instances or memory instances or what the scaling profile is that you want. Or optionally, you can just let Lambda choose for you, and we'll try to continuously benefit or improve your price performance of the workload right off the bat. So thinking a little bit about the use cases, we covered the steady state applications. That is just seamlessly handled now. So the entire gamut of applications, the functionality of your app that requires needlepoint bursts or needlepoint traffic management, that you can leave on Lambda today. If you want the functionality that achieves steady state, real popularity, there's always users to serve. You can move them over to managed instances. The performance critical apps, the real SLA bound apps for which you need specialized instances, they get opened up. The variety of applications open up, from media data processing, web applications, event-driven applications. You can migrate a whole lot more to serverless now. And at times, for those of you who have to struggle with regulatory requirements, struggle is a chosen word, you have some preferences like, hey, I can only use compute in local zone X or in availability zone Y and so on. With managed instances, the mental model will be able to help you there. The other primitive is Lambda's tenants isolation feature. So especially if you're a SaaS builder, and SaaS builder is an analogy, but wherever you need isolation between requests from different tenants that go to the same execution environment, what happens is, builders have to do a bunch of custom tooling and processes, which again introduces pain in the CI/CD pipelines and shipping software cycles. Because what happens is, let's say if you're using a global variable, or if you are storing something to disk of that execution environment, if you try to reuse that execution environment for the next tenant, and you should reuse because that is what improves your utilization and which will drive down your costs, so you're able to increase your margins. So if you try to do that, you have to clean up the execution environment, which reduces your velocity. So with tenant isolation, the only additional thing you have to do to use it is pass in the unique identification of that tenant. Sometimes it's a tenant ID, sometimes it's a JWT token that you use. Pass in anything to us, and we guarantee that we'll give you a clean, isolated execution environment for that tenant. So it again improves your CI/CD cycles, helps you to achieve isolation without any custom tooling whatsoever. Next, we'll switch to how we try to make you well architected by default. So new runtimes. Runtimes is a key component or value prop of Lambdas that we offer to customers. It's basically the programming languages, and I started my career as a developer. I like to use latest features, latest technologies. The performance fixes are baked in, security fixes are baked in. So new runtimes are highly in demand. We provide them to you with full management throughout the life cycle of that runtime. So over the last couple of weeks, we've announced Python 3.14, Java 25, Node.js 24, all available with patching and performance optimizations baked in. Again, what it does, it helps to improve developer productivity. You're able to ship safe software faster. And our mental model here is within 90 days of the runtime being available in the community, we want to make it available to you for use in Lambda. The other thing we do is upgrading the runtimes. Now, upgrading with patches, let's say log4j vulnerability happens, it needs a runtime patch, we do it all for you. But the effort to upgrade runtime is high, particularly if you're one of those who has hundreds of thousands of functions. Upgrading is quite cumbersome. So that is where we found one of the, at least in my mind, one of the great use cases for generative AI. All of that technical debt that you take by not upgrading same day, turns out Gen AI is pretty good at it. So in Matt's keynote today, or yesterday, we announced this new capability called AWS Transform Custom. This provides you, Gen AI-based upgrades. They are incredibly easy to use. They are baked in. You can bake them into your pipelines, into your dev or software release cycles seamlessly. And in previews, we saw that it reduces your tech debt by up to 85%. So 85% of functions you could just accept as is what the Gen AI recommendation was. So go ahead, use it if you would like to upgrade your runtime. Snap start. So serverless introduced the term cold starts in the dictionary. It happens when you initialize your function with your dependencies. We announced snap start for Java a couple years back. We've also announced it for Python and .NET now. So what this does is it takes the snapshot of that entire execution environment when you start the function creation process, or the function deployment process rather, and on subsequent invokes, we restore that snapshot. So your initialization time is really reduced. What we see is the cold start times really benefit, which leads to a lot of happy end users of your applications. There's no code changes required and no custom tooling for you to build. It's just a checkbox that you enable. And then, we are all good engineers. We want to test our applications in spite of the removal of testers from the software cycle in a way. So testing resilience is hard. AWS has this service called Fault Injection Service, or FIS. What it allows you to do is that it allows you to specify your conditions for testing, increase latency, increase, or like make sure a downstream piece like some storage or database is not available for a while, and so on. And then it helps you to see how your application reacts to like those stress conditions. So this integration with FIS helps you to do exactly that. Eventually, what it leads to is like you see how your application reacts to real production scenarios. Helps you to plan and prevent outages better, and have more confidence as you go to bed every night as a developer. Again, no custom tooling required. This is a picture of a type of support that FIS adds to you. You can test for delays here. This picture shows you the graphs of the state of the world with the delay that you see in your application that you would see in production otherwise. And then there's no serverless without event-driven patterns, so we have to do something there. With serverless, one of the key things that developers tell us is that they don't have access to the underlying hardware, so observability is hard, and it needs to be better. Especially as we poll the event sources like SQS or Kafka triggers on the customer's behalf, and lack of visibility into this polling mechanism was a hindrance, because what they had to do was they had to piece together the metrics that the Kafka or the SQS event source provides with what the Lambda function provides. So what we did was we enabled additional CloudWatch metrics. So you see the polar count and lag and throttles right there. This helps you again to detect your issues instantly, increase or improve rather your time to resolution, and again, no custom tooling required. Here's a picture of some of the additional metrics that you now get. Schema registry, so customers that use Kafka in particular try to use the Avro format. Avro supports schema evolution, and it's just easier to deserialize, serialize. But we didn't support Avro format before, so the pain was, builders had to manually add boilerplate code to every function that they want to use to process their Kafka events. What we did a couple months back is added this capability to auto-serialize and deserialize Avro events. This also gives you ability to specify your schemas and evolve your schemas, leading to less code. And with less code, as you know, it's less errors, adds schema evolution support, and again, no custom tooling required. Provision mode, the faster we try to scale up for customers, the faster they want to go further. So for some of the customers, they wanted even faster scaling. That required them to have specific control over the concurrency that they specify for the polling mechanism. So this feature, provision mode for SQS, enables them to pre-warm capacity to handle any spike instantly. We released provision mode for Kafka last year at reInvent, so this is a follow-up for SQS. Again, it helps to eliminate delays as your spikes happen, helps you to meet SLAs, optimize costs, and no custom tooling required again. Now, accelerating developers, this is again to help the developers to ship software faster, not just generate code faster. And when we talk to developers, what they say is like they go to the console just to test the feature, do basic hello world capabilities. But after that, they try to develop in their local machine's IDE. Oftentimes, it's VS Code. And then they try to test locally. That is what drives the faster accelerated ship cycles or the development cycles in this phase. And then before deploying to production, they want to test in the cloud. So these three integration points, or these three deflection points, is what we capitalized on, and we converted them into three features that help you to accelerate your ship cycles. So the first is seamless console to IDE transition. What it allows you to do is, like, as you build the bare bones application on the console, with a single click, we package in all of the dependencies for you, and it starts to light up on your local IDE. You can start immediately coding on your local ID without doing any additional manual work or downloading or so on. Second is local testing. So LocalStack is an AWS partner. They assist with emulating and simulating a bunch of AWS services. And an application is not just the function, but it's comprising of storage and database and networking and so on. So what LocalStack allows you to do is to do all of this locally in your IDE. So with LocalStack, we're deeply integrated now. It helps you to develop offline fully on your local machine, test on your local machine, leading to faster iterations of your business logic without any additional custom tooling that you need. And finally, at this phase, you're at the place where most developers say, hey, it works on my machine. Sucks to be you, it doesn't work on your machine. But you want to be good people, and you want to test in the cloud before to get a feel of what real world looks like before you deploy. So remote debugging enables you to do exactly that. With 2 clicks, you can simply enable your checkpoints or breakpoints, analyze your variables and source code the way you do locally while the code runs in production. So additional test cases that you can cover here are like your IAM policies or permissions, your roles, your database connectivity, so your VPC and network paths and so on, without any additional custom tooling. And with the MCP server that we released in Q2, our idea was to enable best practices to be baked in. Because customers tell us generative AI assists in accelerating coding, but that code is not production ready. There's not much by way of input validations or error handling or status codes and so on. So our MCP server bakes those best practices in it, so your coding assistant can actually generate better quality code. It's more consistent quality that helps in reducing your code review cycles as well, overall accelerating your velocity. And we have support for web apps. This is just a key picture that shows you how we list and deploy web apps. And then we also added support for event-driven applications here. So the MCP server can now help you to set up your Kafka triggers and complete your event-driven architectures as well. So there's some other sessions on serverless, and there's some not here. If you're interested here, like some capabilities like durable functions that was announced earlier this morning. Because this session was within 4 hours, I didn't have the permission to cover it. But tomorrow's session, we will cover that in great detail as well. Please join us. And our roadmap is now on GitHub. We welcome all participation there. Any feature requests you have, or any courses you want to give us, we might delete those posts, but we will read them at least. To delete, you also have to read. But please engage in discussions there. We're fairly customer obsessed, deeply customer obsessed rather, and we'd love to get your input into what we should build next. And if you want to get enabled in any private previews, developer previews, we can have the conversation there. Thank you very much for joining me today. I know I spoke like a train. It was really 20 minutes compressed. A bunch of stuff that I could include, I had to delete. But please join us in the other sessions. We would love to have you there. And like I said, I was holding you from lunch or for lunch, from lunch. Stick around or get lunch. But it was great to connect with you today. Okay, thank you so much.